Okay, so this is the problem from today, the first derivative test, and I wanted to get you started on that so you can see how we do it. Okay, we're told that f of x is equal to this, and I'll go ahead and just write it down like that. We also know that f prime of x is 12x cubed plus 3ax squared plus 2bx plus c. Now, this is going to give us a clue. We've got four unknowns, and we actually have four equations buried in here that we need to figure out. Okay, this point is going to give us two of those equations. We know that f of 0 has to be 7, because the point is 0, 7. And we know that f prime of 0 has to be 0, because we're told there's a horizontal tangent when x is equal to 0. Well, if f of 0 equals 7, plug in 0 and 0 and 0 and 0, and the only thing left is d. So that implies that d is equal to 7. Same analysis on the derivative function here implies that c is equal to 0. So we've actually simplified our function a bit. Now f of x is equal to 3x to the fourth plus ax cubed plus bx squared. The c is 0, so it goes away, plus 7. And f prime of x is equal to 12x cubed plus 3ax squared plus 2bx, and c is 0, so that's a 0. Okay, now we can get the other two equations from that point. We know that f of 2 has to be 7, and f prime of 2 has to be 0. So let's plug in into equation 1 the f of x. Let's plug in f of 2. Okay, 2 to the fourth is 16 times 3 is 48 plus 8a plus 4b plus 7 has to equal, no, wait a minute, that's not a negative 3. Oops, let me erase that. That is actually a negative 3. I knew something didn't look right. Okay, so let's fix that up. Equals negative 3. So equation 1 simplifies down to this. 8a plus 4b equals 48 and 7 is 55. Negative 55 over here is negative 58. Let's take equation 2. F prime of 0, or f prime of 2, is equal to, okay, let's see, 12 times 8 plus 3a times 4, that's 2 squared, plus 2b times 2. I just stuffed the 2 into the derivative equation. And so equation 2 becomes 96 plus 12a plus 4b. Okay, now we have here two equations. We've got that one, and this one is supposed to equal 0. And we have this one. Okay, I can clean this one up just a little bit more. I'll make it 12a plus 4b is negative 96. There, so we'll use that. Okay? Now let's take those two equations, and now we can figure out what a and b are. 8a plus 4b is negative 58. 12a plus 4b is negative 96. Remember from two equations and two unknowns? If you subtract this equation from that equation, you get negative 4a. These go away, and negative 58 minus a negative 96 is, what is that, 38, positive 38. So a is equal to negative 19 over 2. I just divided by negative 4 and reduced it. You can figure out what b is by, let's take negative 19 halves and let's put it in here. So 8 times negative 19 halves plus 4b is negative 58. This simplifies to 4b is equal to 18, and b is equal to 9 halves. So that's what we found out. A is negative 19 halves, B is 9 halves, C is 0, D is 7. Okay, and that's going to be what we're going to use for the next part. Okay, what I did is I just transferred the A, the B, the C, the D to this new page, and I rewrote the function and its derivative based on what A, B, C, and D are. Okay, so here's the 3x to the fourth, and then the A and the B and the C, remember, is 0, so I left it out, and the D is 7. And then f prime of x I just got by finding the derivative of this function. Okay, so now we can figure out where the third critical value is. Remember, it said that right up here there's a third point that has a horizontal tangent. So that means there are 3 places here where we have a horizontal tangent, and that means there are 3 places that give us critical values. So that means that x equals 2 and x equals 0 have to both be critical values of this function, which means they have to be factors of this function. And so I'm going to go ahead and stop this, and then you can go ahead and take a look at part 2, and then we'll explain how we did that.